Hey, hi. I'm Laurent. I work on the Stargate team in Facebook infrastructure, and I'm going to talk about how to clone database as fast as possible at the speed of light with WDT for warp speed data transfer. So if you have like systems in production and you have more than one database, it's a fairly frequent use case that you want to be able to rebuild them, rebuild a failed replica, another slave, or distributing base index across multiple machines. RocksDB is kind of helpful for that because having only mutable files, there's a bunch of optimization you can take into account to make the process more efficient. So systems in the past used to use very simple solution like rsync or SCP or some HTTP-based transfer to transfer a lot of files. But what has changed? Well, as you know, we have more and more data, and we also have machines with more cores. So having a single-threaded system is not the most efficient use of the machine when you need to go as fast as possible. But more importantly, the storage has changed recently, right? So we have now Flash, and on the Flash, there's no cost to seeking multiple times when you have a file with multiple blocks. So you can seek and send those blocks right away. And our networks are becoming faster and faster, but you can't quite beat the speed of light. So latency is also a factor in the throughput that you can achieve. So the earlier solutions that we had a couple of years ago when we started to think about that problem were slow and typically bound in either CPU or a single I/O bound. So we did not have a good solution. We looked around, we did not find one, so we decided to write WDT. And so what are the key principles? Well, we try to make the WDT as high performance as possible. And the key insight, I guess, is to use multiple connections. It helps. You get a better advantage at Facebook because we use software-defined networking. So by using multiple sockets, you actually end up using multiple paths on the network, which might have different congestions from one another. But even if you don't have software-defined networking, by having multiple connection, you multiply your TCP buffers, for instance, and you can do things in parallel. So the other aspect is pipelining. As soon as we have the beginning of the list of SST files that we have to change, we start sending them. We start cutting it into blocks right away, and we start sending it and assembling it on the other side. We are warming up those TCP window and those sockets. And so, yeah, that takes advantage of the structure of RocksDB being immutable files or files that only grow past the offset, append only like the write-ahead logs and manifest. And we try to build this as a very efficient embeddable database. So embeddable library. So there's a command line tool, but it's embeddable, so you can run it in your application like you embed RocksDB. You can embed the data transfer. So in a real system, when everything goes fine, you make one transfer, there's no error, everything is perfect, and you get the best throughput. But what's important in real systems is also to deal with failure. So you have socket errors, you have a bunch of different errors that can happen, and we make sure that our process is resumable and that we optimize for the best case, but we're also able to send checkpoints and resume at the correct point. And because we use AES GCM encryption, we're able also to validate each block and be able to resume at the correct last valid block. So when you go as fast as possible and it's a production system, one thing that may happen is you might overload either the source system that's still being used to serve other shards or the destination system. So it's important to control the resources that you're using. We have a lot of tricks and optimizations and things that we learned along the way by deploying in our environment to make that better. And that includes also obviously some throttling so you can control the speed. So that's an example like taken from last week, a random production system. We can send 100 gigabytes of data in less than 2 minutes cross between Europe and the US. This is not the worst case I found, obviously, but so we use it a lot. inside Facebook. It's like battle tested by now. It's typically 10 times better than those solutions that like rsync, SCP, and so on that were used before. and not only 10 times better in terms of duration of transfer, but also in terms of efficiency. Like it takes less resource and goes faster. There's half a dozen use case, very wide variety from tiny databases that are only 1 megabyte, but lots of transfer to much larger database in the terabyte. Every day we transfer 9 petabytes. Those are like the graph from, so it varies from day to day depending on maintenance and other reason why there's a transfer. But our largest use case transfer more than 10 petabytes, a big stack of disk per minute. And so I invite you to get it. It's open source. It's on GitHub. It's also integrated in part with MyRocks to do the hot backups. And there's a lot of things we still want to do and welcome contributions.